exam is the largest that we'll cover throughout this course. It will make up about 33% of the questions you'll encounter. Now, jumping into AWS for the first time, it can be really overwhelming to try and take in all of the services that are available. In fact, there are over 200 of them. Throughout this course, we'll be focusing on only the services that you may encounter on the Certified Cloud Practitioner exam. One of my favorite quotes from reInvent 2021 was when Dr. Werner Vogels said this, "But remember, you have asked for this. It's basically your fault." Now, this is a funny quip about how customers ask for services, AWS builds them, and then customers complain about how many services are available. Now, while this is pretty funny, it also shows us how we should think about services on AWS. We need to think about not only what the service does, but what is the business use case that drove that service into existence. So as you learn about these services, keep that in the back of your mind. What does the service do, and who is using the service? Now, let's take a closer look at what we're going to cover in this section of the course. As you can see, this page is set up like a table of contents, so you can always come back here and navigate to those services that need more review. As always, you can find this interactive diagram in the Resources section of this course. While it may be tempting to jump ahead, I highly recommend you watch all the lessons in the course, then go back and review those sections where you feel like you have the weakest understanding. Now, we're not going to cover all of these services individually, but let's talk about the different categories of services that you may encounter. First, we're going to talk about compute services, how you can provision compute from AWS. Then there's storage and content delivery. There's networking, which tends to focus on how to connect your local environment to AWS. You'll learn about databases and the myriad ways you can provision databases on AWS. You'll learn about migration and transfer, how to get your services from on-premise into the AWS cloud. You'll also learn some analytics services, services that help you make sense of your data. You'll learn about machine learning and developer tools. Finally, you'll learn about deployment and infrastructure management, messaging and integration, and then you'll learn about auditing, monitoring, and logging, services which you'll use to keep an eye on other services in your AWS accounts. That's all for this short introduction. When you're ready, please join us in the next lesson.
Let's talk about servers, instances, and EC2. Alfredo's Pizza. They have waiters and waitresses taking your requests and giving it to the chef working the brick oven in the back. And they return to you what the chef prepares. Hot, delicious pizza. The waiters and waitresses are like servers in the cloud. They handle your requests and they give you a response. Elastic Compute Cloud. The name says it all. EC2 allows you to rent and manage virtual servers in the cloud. You have elastic compute power. Elastic simply means that it can grow and shrink like a rubber band or like pizza dough based on the needs or the load on your application. And it's virtual servers in the cloud, meaning it's compute or processing power in the cloud. Let's talk about the bigger picture. How does EC2 fit into the bigger picture? Now, this section should be a quick review for you. Let's look at the region first. Northern Virginia. It's a region that falls under the geographic location of US East. And remember, a single region contains multiple AZs. And a single AZ or availability zone contains multiple data centers. And remember, a data center contains multiple servers. Let's look more closely at one of the data centers in availability zone C. This data center has multiple servers. Remember, servers are the actual physical compute hardware running in the data center. And then an EC2 instance is a virtual server running on that physical server. And this shows you that instances are not considered serverless because they actually exist on servers somewhere in a data center. EC2 is a foundational piece of AWS's cloud computing platform. Let's take a closer look. First, you're able to provision an EC2 instance using the console at the click of a button. 2, you can use a pre-configured template called an Amazon Machine Image, or an AMI, to launch your instance. Now, this template provides just the information required to launch your instance, like the operating system. And number 3, you can deploy your applications directly to your EC2 instances. And lastly, number 4, you receive 750 compute hours per month on the free tier plan. Let's discuss EC2 in the real world. When would you want to use an EC2 instance? Let's say you have a database. You can deploy a database to EC2. You'll have full control over that database. You can also stand up a web server and deploy a web application to an EC2 instance. And if you deploy to multiple AZs, that web application will be highly available. There are several common ways to access your EC2 instances. The first is through the AWS Management Console. You're able to configure and manage your instances through a web browser. Next, you can use SSH, Secure Shell. That allows you to establish a secure connection to your instance from your local laptop. Next, you can use EC2 Instance Connect. With this, there is no need to install an SSH client, and you can use IAM policies to control access to your instances, removing the need to manage SSH keys. Another common way is AWS Systems Manager. Through its Session Manager, you're able to manage your EC2 instances through an interactive one-click browser-based shell or through the AWS CLI. The most common way to connect to Linux EC2 instances is via SSH. And the first thing you'll do is generate a key pair. A key pair consists of a private key and a public key, and it basically proves your identity when you're trying to connect to or log into an EC2 instance. So once you have your key pair, you connect via SSH. You have an SSH client on your laptop that uses the private key, and when you connect to your EC2 instance uses the public key. There are several pricing options to choose from when using your EC2 instance, and it's really based on your use case and your budget. The first is called On Demand. On Demand, it's the typical way that people use it. It's a fixed price in which you are billed down to the second based on your instance type. There's no contract, and you pay for only what you use. Some common use cases for On Demand, it's when you care about low costs and you do not want to make an upfront payment or a long-term commitment. Or if you have applications that have unpredictable workloads that cannot be interrupted, consider an on-demand instance. If you have an application that's under development or your workloads will not run longer than a year, then an on-demand instance works great for those. Fun facts about an on-demand instance: you can actually reserve capacity using on-demand capacity reservations. This capacity is held for you whether or not you run the instance, but sometimes it is good to know that that capacity is there whenever you need it. Next, we have spot instances. Spot instances let you take advantage of unused EC2 capacity across the AWS cloud, and your request is fulfilled only if the capacity is available. So when do you want to use a spot instance? You use it when you're not concerned about the start or stop time of your application, or if you have workloads that can be interrupted, or your application is only feasible at very low compute prices. And the fun facts for Spot: you can save up to 90% off of on-demand instances. So that makes Spot the cheapest option. And you pay the spot price that's in effect at the beginning of each hour. Next, we have reserved instances. You're basically making a reservation, like the name says. It allows you to commit to a specific instance type in a certain region for 1 or 3 years. You use reserved instances when your application has steady state usage and you can actually commit to a 1 or 3 year term. Reserved instances also make a great use case for when you want to pay money up front in order to receive a discount off on-demand prices, or your application requires a capacity reservation. Fun facts: you can save up to 75% off on-demand prices. Now, with reserved instances, you are required to sign a contract for either 1 or 3 years. And you can reserve capacity in an availability zone for any duration, and you pay all upfront, partial upfront, or no upfront. And all upfront for the max term earns you the highest discount. One other neat thing about reserved instances, it provides what's called a convertible type at only 54% discount off of on-demand prices. And you use a convertible reserved instance if you need additional flexibility. For example, you may want to change the instance family or the operating system or the tenancy model, and then you're able to do that even though your instance is reserved. The next is called dedicated host. Now, this allows you to pay for a physical server that is fully dedicated to running your instances. That means no other AWS customer is going to have applications running on this server. The server basically belongs to you. You use dedicated hosts when you want to bring your own server-bound software licenses from vendors like Microsoft or Oracle, or if you have regulatory or corporate compliance requirements around the tenancy model. Some fun facts about dedicated hosts: you can save up to 70% off on-demand prices, and you bring your existing per socket, per core, or per VM software licenses. And like I mentioned, there is no multi-tenancy. That means the server is not shared with other customers. And don't confuse a dedicated host with a dedicated instance. I know it's easy, they sound similar, it's easy to get them confused. Now, the dedicated host is the actual physical server, whereas the dedicated instance runs on the host. Lastly, we have savings plans. Savings plans allow you to commit to compute usage that's measured per hour for 1 or 3 years. So this is just the actual compute usage. And you use a savings plan when you want to lower your bill across multiple compute services. And you also want the flexibility to change compute services or instance types or operating systems or regions. Now, a few fun facts about savings plans: you can save up to 72% off on-demand prices. And with this, you're not making a commitment to a dedicated host, just to compute usage. And your savings can be shared across various compute services like EC2, Fargate, and Lambda. Now, with savings plans, this does not provide a capacity reservation. Now let's talk about features. EC2 instances offer load balancing and auto scaling. What is elastic load balancing? It's exactly what it sounds like. It balances the load or the requests and the traffic across a set of servers. Using Alfredo's pizza, think of it like a greeter, someone standing at the door and directing a person to go to a certain line. Elastic load balancers act the same way. And there are several different types of load balancers. We have classic load balancers, application load balancers, gateway load balancers, and network load balancers, but they all act in the same manner. Now let's talk about auto scaling. Auto scaling adds or replaces EC2 instances across availability zones based on need and changing demand. So think about it like this. Your system could go from 2 server instances to 3, or 3 down to 1 based on need. Autoscaling is very important because it reduces the impact of system failures and improves the overall availability of your applications. You can also use autoscaling with other services like DynamoDB and Aurora. Now, there is this important note here. Do not confuse horizontal scaling with vertical scaling. Whenever you hear the term vertical scaling, think about upgrading. So you're scaling up. You're upgrading your EC2 instance by adding more CPU and RAM to an existing server. Whereas horizontal scaling or scaling out is when you're adding or removing servers. Review time. What did we talk about? We talked about an EC2 instance. That allows you to rent and manage virtual servers in the cloud. And AWS's virtual servers are called instances. Connectivity. We looked at the multiple ways to log into your EC2 instance. And this is a list of the most common ways: the console, SSH, EC2 Instance Connect, and the AWS Systems Manager. We talked about the multiple pricing options and when you would want to use one pricing option over another. We looked at on-demand, spot, reserved instances, dedicated hosts, and savings plans. And features. We looked at elastic load balancing. That's the greeter standing at the door directing traffic. It automatically distributes your incoming application traffic across multiple EC2 instances. And then we looked at EC2 auto-scaling. That adds or replaces EC2 instances automatically across availability zones based on need. Going into the exam, there's a lot that you need to remember in this section. First, the EC2 pricing options. Make sure you understand on-demand, spot, reserved instances, dedicated hosts, and savings plans. Make sure you understand horizontal scaling versus vertical scaling. Horizontal scaling is called scaling out. That's where you add servers. And then vertical scaling, think about scaling up. Think about upgrades. You're upgrading an existing instance. Also, know the types of load balancers: classic, application, gateway, and network. And don't forget the benefits of auto scaling. It improves the availability of your applications. And don't confuse auto scaling with load balancing when you're going into the exam. Make sure you understand the real-world usage of EC2 instances, like deploying a database or a web application. And then understand how to connect to an EC2 instance using SSH from your local machine. And you'll need a key pair in order to do that. When you're ready, please join me in the next lesson.
Hello Cloud Gurus, and welcome to this lesson, EC2 in Action. In this lesson, we're going to walk you through how to provision an EC2 instance and start getting you familiar with the console. So without further ado, let's hop right in. Here, I'm logged into one of Cloud Guru's AWS Sandbox accounts as Cloud User. And all of the most recently visited services automatically are populated on the front page. If you're using your own AWS account, you may not have any recently visited services, and so you'll have to find EC2 yourself. If you're exploring the services that AWS has to offer, I recommend using this services menu, which opens up and gives you categories for the many different services found in AWS. To find EC2, we can navigate to Compute, and here we see EC2 in this menu. If you know exactly which service you're looking for, you can always go to the search bar here, and this is probably my most commonly used method. Type in EC2, and here you can see EC2 has populated in the search. So let's go ahead and navigate to EC2 and see what that looks like. So that brings us here to the EC2 dashboard. If I wanted to get back to that home screen page, I can always click this AWS icon here in the corner. Now, here we can see we have no instances running, and no instances provisioned at all, it's important to note that we are in the North Virginia region, and if I had instances in other regions, they would not show on this page. So let's go ahead and launch an instance. Here we'll click the Launch Instance dropdown and select Launch Instance. Here we are in the EC2 Launch console. We'll start by giving our instance a name. We'll call it Example Instance. Next, we get to choose the operating system and Amazon machine image for this instance. An Amazon machine image, or AMI, is basically a stable snapshot of a virtual machine that you can spin up and expect it to be the same every single time. We're going to choose the Amazon Linux 2 AMI, which is a very popular free tier option. Next, you can choose the instance type. T2 Micro is the default, which we're going to go with because it's free tier eligible. But if I open up this menu, you can see there are many, many different types of instances. Now, this can look overwhelming at first, but just know that the different families and sizes are designed to be flexible depending on how much compute, memory, or network bandwidth you need. We're going to stick with T2 Micro for this example. Next, you can generate a key pair so that you can connect to your instance. To do so, I'm just going to click Create New Key Pair. I'll call it My Key Pair, and I can leave the rest of these default. This will automatically download the private key to your machine, and the matching public key will automatically be configured on your EC2 instance. Next, we get to choose the network settings. Here, you can choose which VPC or subnet you're provisioning your EC2 instance in. I'm going to leave these as default. You can also edit the default security group. Security groups determine what types of traffic and from where can reach your EC2 instance. For our purposes, we can leave this to SSH traffic from any IP address, but in a production environment, note that you should probably lock this down a little bit more, and that's what this little warning is about down here. We can also configure our storage, adding new storage volumes or increasing the size or adjusting the type of the root volume. There's an advanced details menu where you can override a lot of the default behavior around auto recovery or shutdown. You don't have to worry about this for now, but just know that it's there. So now let's go ahead and click Launch Instance. And here it should only take a few seconds to actually create the instance, and it will take a few more seconds, or maybe up to minutes, for it to actually start. So here we can look at the status and see that it is not populated currently. I'll hit refresh. So here we can see the instance state is pending. And as soon as it's active, that will turn green and we should be able to connect to that instance. There we go. We can see that the instance is running. So let's go ahead and select this instance and hit connect. We're going to connect using EC2 Instance Connect. Let's just go ahead and hit connect. We'll be brought to a new page where the console will pop up. And now we're connected to our EC2 instance and we can start typing our commands. So that's a very short overview on how to create, configure, and connect to an EC2 instance. I hope you enjoyed this lesson. This has been David Blocker, and I'll see you in the next one.
Let's talk about one of my favorite compute services, AWS Lambda. Lambda is a serverless compute service that lets you write code without managing servers. And believe me, for developers like myself, it's a dream come true. We can focus on our code and not worry about managing servers. The code you write is called a function, and you can author functions in many popular programming languages. Lambda scales automatically, and it's serverless. That means you don't have to worry about managing servers like with EC2. The bigger picture. Let's discuss how Lambda fits into the bigger picture and why it is a developer's dream come true. Developers build apps by writing code, and Lambda actually allows developers to focus on the core business logic for the apps they're developing, instead of worrying about managing servers, doing things like patching, provisioning, and scaling. How would you use Lambda in the real world? Lambda is a building block for many serverless applications. Serverless simply means AWS manages the servers for you and you cannot access them. You can pretend that they don't exist. There are several use cases for Lambda. The first could be for real-time file processing. Let's say you have a data file that you upload to an S3 bucket. And when that upload happens, it triggers a Lambda to read that file and store that data in a DynamoDB table. Another use case would be sending emails. Let's say you want to use Lambda and the simple notification service to get very detailed file change notifications from code commit. Here we have code commit. Whenever there's a file change, it triggers CloudWatch, which then triggers a Lambda, which triggers SNS to send an email. Lambda is also used for the back-end business logic. Whenever I develop Alexa skills, the back-end is typically a Lambda function that retrieves values from a database like DynamoDB and sends that information back to Alexa. Now let's talk about features. The first feature is that it supports popular programming languages like I mentioned before, languages like Java, Go, PowerShell, Node.js, C#, Python, and Ruby. So there is a large footprint of languages supported by Lambda. And number two, you can author your code using your favorite development environment locally and upload, or you can write the code via the console. Now you're only responsible for the code you write, making sure it's secure, while AWS manages the coding environment and the supported language versions. For number three, Lambda can execute your code in response to events. In the real-world example, we saw Lambda being triggered when a file is uploaded to S3. And number four, Lambda functions have a 15-minute timeout. So just remember that whenever you're designing your serverless architecture. Lambda is typically not good for processes that run longer than 15 minutes. Now let's see Lambda in action. I've navigated to the AWS Management Console. You can get to the Lambda dashboard several ways. You can type Lambda here and click on Lambda. This is the Lambda dashboard. It lists all of your functions. There are no functions, so we need to create a new one. Click on Create Function. We are going to select Author from Scratch. Start with a simple Hello World example. I'm going to give my function a name, my test function. We'll leave the runtime as Node.js and leave all of the other defaults and click Create Function. Now we have this message, successfully created the function myTestFunction. And this is the dashboard for the function itself. There are several tabs here. We're most concerned about the code, so we're going to write the code. Notice they give you a sample index.js file here with sample code that just simply says hello from Lambda. I am going to replace that with my sample code. And this code you can copy and paste. I've included a link in the resources section so that you can pull up this code and just do a simple copy and paste. And all this code is doing is connecting to a URL. And if everything works, we'll see a response status code of 200. So I've entered my code here. And in order to test it, you have to configure a test event. In this example, we'll just leave the default. We'll call it my test event. I'm not actually passing anything to the function, but we'll leave the default as is and click create. You have to create a test event in order to test a function. And now we've created the test event. We've authored the code. We have to click deploy to deploy the changes. And now we can actually test it. Click on test. And this window here shows the execution results. And notice the response is 200. So it was actually able to access that URL. Here it shows the duration. Remember, that's one of the attributes that determines how much you pay for your code execution. Well, that was a quick look at creating a Lambda. Let's talk about the Lambda pricing model. You are charged based on the duration and the number of requests. Let's talk about the compute time. You pay only for the compute time used, so there's no charge if your code is not running. And the duration is calculated from the time your code begins until it returns or otherwise terminates. Next, you have the request count. A request is counted each time execution starts. Even if you're just testing it using the console, that will count as well. One neat thing about Lambda, it has what's called this always free tier. So that means the free usage tier includes 1 million free requests each month. And that's even after the free tier ends. So Lambda is basically always free. It's review time. What did we learn? We learned about Lambda. Lambda is a serverless compute service that lets you run code without managing servers. And it has several features. It supports many popular programming languages, and you can author your code using your favorite development environment, or you can author it via the console. And we talked about pricing. Pricing is based on the compute time, request count, and then you have that always free option. Going into the exam, when dealing with Lambda, remember what is your responsibility versus AWS's. For example, you are only responsible for your application code. AWS manages servers, the coding environment, and language support. And going into the exam, remember the pricing model for Lambda. Lambda has an always free option that even after the free tier usage expires, you have access to 1 million free Lambda calls each month. When you're ready, please join me in the next lesson. In this lab scenario, Alfredo's Pizza's web app, where they process customer orders, is going serverless. No more wasting money relying on expensive, always-on servers. Alfredo will save money on operating costs using AWS Lambda. And that's where you and I come in. We'll show him how easy Lambda functions can be. If you look at this code, you're going to write a Lambda function in Python. Python in this case is not a snake. It is a computer programming language. And don't be alarmed if you're not a coder. As you can see, I've already written the code for you, and I've provided a link to it on the lab start page, and I'll show you how to copy and paste later. During this lab, you'll have an opportunity to explore the Lambda console, function code, execution roles, test events, and execution results. Lambda will write its output to logs that are served up via CloudWatch. After you write and test your code, you'll visit CloudWatch to review the logs. Your next step is to log into the live AWS environment using the provided credentials on the lab start page. Make sure you're in US East 1 when you work in this environment. Let's get started. Welcome back. In this video, we'll author our Lambda function in the console using the Python programming language. Our simple function will output your name and the phrase, "Keep being awesome." If you notice here, I have 3 tabs open. The first is the AWS Management Console. The second is the GitHub link I provided to you. This is the code for our function. The third is the code for our test event. Now let's navigate back to the AWS Management Console, and let's go to the Lambda console. In the search bar at the top, type Lambda, and then select it. This brings us to the Lambda dashboard. To create a new function, click Create Function over here on the right-hand side. You have several options. We're going to choose this Author from Scratch option because I've given you the code already. Under function name, type my function. Under runtime, make sure you select the latest version of Python, whatever that may be for you. In my case, it's 3.7. Under permissions, let's expand change default execution role. Anytime a Lambda function runs, it's going to assume an execution role to determine its access permission. So What can it do? What does it have access to? In this case, we're going to create a new role with basic Lambda permissions, and all this will do is give the Lambda function access to Amazon CloudWatch logs. Scroll down to advanced settings. We don't need any of the advanced settings for our simple scenario, no code signing, and no VPC. Over here on the right-hand side, click Create Function. And this may take a minute. Great, now we've successfully created our function. And this is the function dashboard. Let's scroll down. If you notice here, there are several tabs: code, test, monitor, configuration, aliases, and versions. Make sure you are on the code tab. Down here, it's given us sample code. Click on lambdafunction.py, double click on it, and then this shows you the sample code. We're not going to use this sample code. I've given you the code already. So navigate back to your second tab and copy and paste the Lambda code. Copy, go back, and paste. I'm gonna fix the formatting a bit. Okay, that looks good. The next step is to deploy your code by clicking on the Deploy button. Successful message, your changes have been deployed. Now, if you notice here, the Lambda console actually uses Cloud9, it's a separate developer service, to provide an integrated development environment in the browser. All right, we've deployed our code. The next step is to test it. So when you're ready, join me in the next video so we can test our function. Welcome back. In the last video, we authored and deployed our Lambda function. In this video, we are going to create a test event so that we can test our function. And I just want to explain to you what is going on here in the code. On line 4, I'm creating a message variable and I'm assigning to it hello, and these are like placeholders, keep being awesome. And then here I'm getting the value passed in for first name, the value passed in for last name. Here on line 7, I'm printing a message to the CloudWatch logs. And on lines 9 through 11, I'm returning the value in this message variable. Okay, now let's navigate to the third tab. This is the code for our test event. Copy this, and let's go back to the Lambda. And the first step is to click on this arrow next to the word test and click Configure Test Event. We're going to create a new test event. Let's call it My Test. And this is where we copy and paste the JSON. And let's click Format JSON. I like this better. It just makes it easier to read. Here on line 2, get rid of this and replace it with your name. On line 3, get rid of that and replace it with your last name. Notice first underscore name is going to hold your first name, and last underscore name is going to hold your last name. Then click Create. And now it's created the test event for us. In order to test it, click on Test. And you'll notice the execution results. And we see here, hello, Keisha Williams, keep being awesome. Notice in the response window down here, the duration and the build duration. The duration is the execution time, and the build duration is the time you're actually billed for. Feel free to play around with changing the test event. To get back to it, you click on this orange button and you click Configure Test Event, and it defaults to the test event that you just created. So you can change things here just to play around. But great job at testing your first Lambda function. When you're ready, join me in the next video and we'll take a look at the CloudWatch logs. Welcome back. In the last video, we tested our Lambda using a test event. Now we're going to look at the CloudWatch logs. In order to do that, click on this Monitor tab. This shows high-level CloudWatch metrics about our function, the number of invocations, the duration, the error count and success rate, and more. We need to see detailed logs in CloudWatch. In order to do that, click View Logs in CloudWatch. And this opens a brand new tab, and it brings up the CloudWatch logs for our function. When you come to this screen, the most important part is log streams. And this shows the logs across multiple executions of your function. So you may have multiple log streams. Click on the most recent one. And here it shows when the request started, when it ended, the duration and the build duration. And here, let's expand this. It also shows the output. So remember, we had that print statement in our code. The print statement actually produced this message in the log file. Congratulations for creating your first Lambda function using Python. I think you are officially a coder. I'll see you in the next lab. Welcome back. In the last video, we tested our Lambda using a test event. Now we're going to look at the CloudWatch logs. In order to do that, click on this Monitor tab. This shows high-level CloudWatch metrics about our function, the number of invocations, the duration, the error count and success rate, and more. We need to see detailed logs in CloudWatch. In order to do that, click View Logs in CloudWatch. And this opens a brand new tab, and it brings up the CloudWatch logs for our function. When you come to this screen, the most important part is log streams. And this shows the logs across multiple executions of your function. So you may have multiple log streams. Click on the most recent one. And here it shows when the request started, when it ended, the duration and the build duration. And here, let's expand this. It also shows the output. So remember, we had that print statement in our code. The print statement actually produced this message in the log file. Congratulations for creating your first Lambda function using Python. I think you are officially a coder. I'll see you in the next lab. Let's talk about additional compute services. Don't forget that you can follow along with me by using the web page associated with this lesson. In this lab scenario, Alfredo's Pizza's web app, where they process customer orders, is going serverless. No more wasting money relying on expensive Let's talk about additional compute services. Don't forget that you can follow along with me by using the web page associated with this lesson. I've included a link for you in the resources section and in the lesson description. You may have heard the term containers. Let's say Alfredo wanted to pre-make his pizza and sell it already made in the frozen pizza aisle. It's the concept of grab and go. This pizza can be placed in any oven and cooked, and it will be the same delicious pizza over and over again. That's what containers are. It's like you have the same application placed in a container that can be transported and deployed to different services, and it will be the same application over and over again because it is a self-contained unit. Let's talk about Fargate. Fargate is a serverless compute engine for containers. Fargate allows you to manage containers like Docker. If you've never heard of Docker, it is the leading container technology. And Fargate actually works with Amazon Elastic Container Service, ECS. It scales automatically, and it's serverless, meaning you don't worry about provisioning, configuring, or scaling servers. And this actually removes the need for you to interact with or even think about servers or clusters. Lightsail. Lightsail allows you to quickly launch all the resources you need for small projects. You can deploy pre-configured applications like WordPress websites at the click of a button. Lightscale has simple screens for people with no cloud experience. And it includes a virtual machine, storage, data transfer, DNS management, static IP, really everything you need for your project. And it provides a low predictable monthly fee, some fees as low as $3.50. Lightsail is great for very simple workloads, quick deployments, and just getting started with AWS. It's designed to help you start small and then scale as you grow. AWS Outposts. Outposts allow you to run cloud services in your internal data center. And it supports workloads that need to remain on premises due to latency or data sovereignty needs. Now, data sovereignty is also considered data residency. You may have legal, regulatory, or contractual requirements that require you to keep your data in a particular location, and Outposts can assist you with that. AWS actually delivers and installs servers in your internal data center. This is used for a hybrid experience. And you have access to the cloud services and APIs to develop apps on premises. Lastly, let's talk about AWS Batch. Batch allows you to process large workloads in smaller chunks or batches, and it's typically used for longer running jobs. You can run hundreds and thousands of smaller batch processing jobs, and it dynamically provisions instances based on the volume. Let's use Alfredo's Pizza to think about how batch works. Let's say Alfredo wants to send out a newsletter to 50,000 customers. To improve processing and overall delivery, he could create a batch job to send out only 1,000 emails at a time. So he's taking this larger workload and breaking it into smaller chunks or batches. Review time. We talked about Fargate. Fargate is a serverless compute engine for containers. We talked about Lightsail. It allows you to quickly launch all the resources you need for small projects. Outposts. It allows you to run cloud services in your internal data center. And Batch. It allows you to process large workloads in smaller chunks or batches. Going into the exam, remember Fargate is considered serverless and is used to manage containers. Lightsail is a compute service that is used to quickly launch pre-configured applications for small projects. And the example I gave you was a WordPress website. Outposts, AWS Outposts support a hybrid deployment model. And remember, hybrid means you have the public cloud and the private cloud, and they talk to each other. And Batch. AWS Batch is a compute service that is used to process large workloads in smaller batches. When you're ready, please join me in the next lesson. Today we're going to talk about Simple Storage Service, or S3, a very popular storage service on AWS. And don't forget that you can follow along with me by using the webpage associated with this lesson. I've included a link for you in the resources section and in the lesson description. I always like to start with the bigger picture and talk about why we need storage in the cloud. Today, companies collect a lot of data and they need a way to store and analyze the data they've accumulated over the years. Storage services simply provide a place for companies to store data. Let's start with S3. S3 is an object storage service for the cloud that is highly available. Objects are stored in buckets. So instead of files and directories, you have objects and buckets. S3 gives you essentially unlimited storage because it can hold millions of objects per bucket. Objects can be public or private. And you can upload objects via the console, the CLI, or through code. Let's take a closer look. One feature that S3 provides is security. So public access is granted to buckets and objects in those buckets through access control lists, bucket policies, access point policies, or all three. You can enable versioning to create multiple versions of your objects to protect against accidental deletion or to roll back to a previous version. You can use S3 access logs to log all the access to S3 buckets and objects, so you can see the root cause of issues or track down any suspicious activity. And S3 is a regional service, but the bucket name is globally unique. So this means after a bucket is created, the name of that bucket cannot be used by anyone else in any AWS region unless that bucket is deleted. Do you remember our discussion on durability and availability? Well, let's dig a little bit deeper. Durability and availability are two very different aspects of data accessibility. Durability answers the question, will my data be there tomorrow? Durability means that you can expect your data to be there. Durability is important so your objects are never lost or compromised. And Amazon S3 standard is designed for 11 nines of durability. Now let's talk about availability. Availability answers the question, how quickly can I access my data? Can I have it right now? Availability is important so you can access your data quickly when you need it. And Amazon S3 standard is designed for 99.99% availability. How can AWS offer 11 nines of durability and 99.99% availability for S3 standard? These are outstanding numbers, by the way. Well, data stored on an S3 bucket inside a region is replicated across multiple servers. And so it gives high availability and durability on a regional level. Now, you can also set up cross-region replication where your data is replicated across regions, but S3 doesn't do that out of the box. You have to set that up. S3 offers several storage classes. And a storage class is just a way of storing your data. And they're designed for different use cases. And it's really all based on your budget and your use case. First, there's S3 standard. So this is general purpose storage for any type of data. Your data is stored across multiple availability zones. It offers low latency and high throughput. And look at the durability, 11 nines, and for availability, 99.99. S3 standard is recommended for frequently accessed data. The next storage class is S3 intelligent tiering. Now, this looks at your data and how you access that data, and it automatically moves your data to the most cost-effective storage class. So with intelligent tiering, and it actually uses machine learning behind the scenes, you have automatic cost savings, no retrieval fees, and your data is stored across multiple availability zones. You have the typical durability of 11 nines and the typical availability. Now, this is recommended for data with unknown or changing access patterns like new applications, or ones with unpredictable access patterns like a data lake. The next storage class is S3 standard infrequent access. Now, this is for data that's accessed less frequently, but requires rapid access when you need it. Again, your data is stored across multiple availability zones, and it is slightly cheaper than S3 standard. This is recommended for long-lived data, data that is infrequently accessed, but then once you need that data, millisecond access is required. The next is S3 one zone infrequent access. Now, this is like S3 standard infrequent access, but your data is only stored in one availability zone. And this actually costs 20% less than S3 standard infrequent access. And now the thing to note about this one, data stored in this storage class can be lost. And that's because it's stored in a single AZ. So if that AZ is totally destroyed, your data is gone. Now, this is recommended for data that you can easily recreate, data that is infrequently accessed with millisecond access required. And availability and durability is not essential. Look at the durability. You have 11 nines, but look at the availability. It's only 99.5%. The next storage class is S3 Glacier. This one is for long-term data storage and archival at very low cost. Now, the thing with this storage class is data retrieval takes a lot longer. And you actually have 3 retrieval options, between 1 and 5 minutes, or between 3 and 5 hours, or between 5 and 12 hours. Here again, your data is stored across multiple availability zones. Notice there's only 11 nines of durability, and it's recommended for long-term backups, and it's a very cheap storage option. Next, we have S3 Glacier Deep Archive. This is like S3 Glacier, but it has longer access times and only two retrieval options, 12 hours or 48 hours. Remember, this is the cheapest of all S3 options. Your data is stored across multiple availability zones. This storage class is recommended for long-term data archival, and it's data that you only access once or twice a year. And it's also recommended for retaining data for regulatory compliance requirements. And look at the durability. It only has 11 nines of durability, no availability. Lastly, we have S3 Outposts. Now, this provides object storage on premises, so in your local data center. It only gives you a single storage class, and you can store data across multiple devices and servers. Now, this is recommended for workloads with local data residency requirements, so data that you need to keep local. It's also recommended for applications that have demanding performance needs, and you need to keep your data close to your on-premises applications. Now let's talk about S3 in the real world. You would use S3 for static websites. You can deploy static websites to S3 and use CloudFront to have global distribution of your application. You can also use it for data archivals. We talked about Amazon Glacier. You can use Glacier as a storage option to archive your data. You can use it for analytics systems. So you can store data in Amazon S3 for use with analytics services like Redshift, which is the data warehousing solution, and Athena, that allows you to query your data in S3 using standard SQL. And then mobile applications. You can actually use S3 transfer acceleration to speed this process up. So you can have a mobile application where users can upload files to an Amazon S3 bucket, and S3 transfer acceleration makes the process very fast. Now let's review. S3 is an object storage service with several storage classes. We reviewed S3 Standard, Intelligent Tiering, Standard and Frequent Access, One Zone and Frequent Access, Glacier, S3 Glacier Deep Archive, and Outposts. We talked about these storage classes and the use cases for each. Going into the exam, remember that S3 is a regional service but has a global namespace. And remember the S3 storage classes. S3 offers unlimited storage with several different storage classes. Going into the exam, make sure you understand the use cases for each storage class. When you're ready, please join me in the next lesson. Welcome. Let's have a quick demo and see S3 in action. Now I'm going to show you how to create an Amazon S3 bucket and upload a file to it. The easiest way to find S3 is to type it in the search bar at the top and then click on the very first one, S3. And this will bring you to the S3 dashboard. Now to create a bucket, it's very simple. Click on the orange Create Bucket. Now let's give our bucket a name. And remember, I told you that although S3 is a regional service, bucket names must be globally unique. So we have to pick a bucket name that no one else has ever used before. So let's call it ACG Test Bucket CCP. I'm hoping that one is not taken. Notice here you have to select the region. And we're just going to leave it in US East 1. Right now, we're going to make our bucket private. Remember, I told you that you had the option to make your bucket and the objects in the bucket either public or private. Right now, the safest solution is to block public access. So we'll leave the default selected. I mentioned to you bucket versioning. For this example, we're not going to turn on versioning, but if you wanted to, you would select enable. Tags are optional. It's just a way to identify your resource. For example, if you wanted to create a bucket that belonged to the IT department, you could add a tag here. We'll leave it empty. The default encryption, we'll talk about encryption later on in our security section. For now, we're going to leave it disabled. And then click Create Bucket. I'm hoping that bucket name, yes, that bucket name is available. And notice the message up here, successfully created bucket, ACG test bucket CCP. Now let's upload a file. In order to upload a file, you click on the bucket name and you can click on upload. Now it's very easy to upload a file to your S3 bucket. You can drag and drop, or you can click on add files. Now I have a file of the ACG logo. I'm just going to drag and drop that right here. And notice the file shows up here. And the final step is to upload it. And now we see the green success message at the top. And that is how easy it is to upload a file to an S3 bucket. When you're ready, please join me for the next lesson. Welcome. Let's have a quick demo and see S3 in action. Now I'm going to show you how to create an Amazon S3 bucket and upload a file to it. The easiest way to find S3 is to type it in the search bar at the top and then click on the very first one, S3. And this will bring you to the S3 dashboard. Now to create a bucket, it's very simple. Click on the orange Create Bucket. Now let's give our bucket a name. And remember, I told you that although S3 is a regional service, bucket names must be globally unique. So we have to pick a bucket name that no one else has ever used before. So let's call it ACG Test Bucket CCP. I'm hoping that one is not taken. Notice here you have to select the region, and we're just going to leave it in US East 1. Join me for the next lesson.
Hello, Cloud Gurus. In this lesson, we're going to talk about additional storage services that you might see on the Certified Cloud Practitioner exam. First, we're going to take a look at a few different types of EC2 storage, where data is stored on your EC2 instances. This will include Elastic Block Store, or EBS, EC2 Instance Store, and Elastic File System. Then, we'll talk about a hybrid storage service called Storage Gateway, and a service used to back all that stuff up, AWS Backup. So let's go ahead and dive into the lesson, starting with EC2 storage. First, let's take a look at how EC2 instances work. EC2 instances are hosted on a host computer or a rack in an AWS data center. These host computers can be split up virtually into many EC2 instances. Individual instances can have different types of storage. All EC2 instances must have a root drive. This could be an EBS volume or an instance store volume. You can also attach multiple EBS volumes to a single EC2 instance, You can think of these as hard drives that you've installed on the EC2 instance. The important distinction between EBS drives and instance store drives is that EBS drives are persistent. You can stop or terminate the instance, or even detach an EBS drive and attach it to a different EC2 instance. Instance store drives, on the other hand, are ephemeral. They have lower latency, but that data does not persist if an EC2 instance is stopped or terminated. In the diagram on the screen, Instance 1 and Instance 2 use EBS drives, and Instance 2 has multiple EBS storage blocks attached to it. Instance 3 leverages multiple instance store drives, and Instance 4, while it has an EBS root volume, it also leverages Elastic File System, or EFS. This you can think of like a shared drive that can be associated with many different instances. And Instance 3 has instance store volumes, which are attached directly to the physical machine. This comes with ultra-low latency, but also has a few key drawbacks that we'll cover later in the lesson. So let's take a closer look at EBS volumes. EBS is a storage service where you can attach volumes to your EC2 instances. These volumes can be attached or detached, and that data will persist. So even when you stop that EC2 instance, the data in an EBS volume persists, just like a flash drive or an external hard drive. One drawback is that an EBS volume can only be attached to one instance. You can have many EBS volumes on a single instance, but a single volume can't attach to multiple instances, just like you can't plug a flash drive into multiple computers. Your EBS volume is also tied to one availability zone, so if you need that data to be moved to another availability zone, you'll have to replicate the block storage. And the most important thing to remember for any of these services are its use cases. EBS is the most common storage service for an EC2 instance. You can customize the size, the data is quickly accessible, and you can store long-term production data on these volumes. Next, let's talk about EC2 Instance Store. An instance store is local storage that is physically attached to the host computer. That means that the instance store and the EC2 instance itself exist on the same physical machine. This comes with advantages as well as drawbacks. The biggest drawback is that storage is temporary. Anytime the EC2 instance is stopped or terminated, that data is gone forever. The big advantage is that the throughput or latency is much faster. Because this data doesn't have to travel over any networks, it's physically attached to that EC2 instance. This is the fastest option for data access. And the ever important use cases. If you have temporary storage needs, or you have multiple instances where data is replicating across them, this can be a great option for when faster I/O is needed in the use case. Now let's talk about Amazon Elastic File System, or EFS. EFS is a serverless network file system for sharing files. If you've ever used Dropbox or Google Drive, this is a very similar concept, except it's for your EC2 instances. The main drawback is that it can only be used on the Linux file system. There are other services for Windows file sharing, but this one is fast and light and designed specifically for EC2 instances running Linux file systems. Your EFS file systems exist across an entire region. This means that EC2 instances that are deployed in any availability zone can access an EFS system in that same region. It's important to note that this is a more expensive storage solution than EBS, so it's important to know when EFS is necessary for your use case. EFS will tend to be used when business-critical applications need shared directories. EFS can also be useful if you're doing a lift and shift on an existing enterprise app that depends on a shared drive in your existing network. Storage Gateway comes in a few different flavors, but really you only have to understand it at a high level. Storage Gateway is a hybrid storage service that you can use when you want to store some data on the cloud and keep some data local and low latency. So if you have a site-to-site VPN or a direct connection to the AWS cloud, you can use Storage Gateway to hybridize your data storage. You can think of this sort of as a file directory where some of the files are hosted locally and some of them are hosted in the cloud. Common use cases for Storage Gateway include moving backups to the cloud, keeping costs low by picking and choosing what data you host in the cloud, and keeping latency low by deciding what data you want direct access to in your local network. Finally, let's talk about AWS Backup. AWS Backup is sort of a catch-all backup service that helps you backup data from EC2, EBS, EFS, and more services across AWS. It's used to schedule, execute, and access backed up data across many AWS services. When you create a backup plan, you'll determine what data you're backing up, how frequently you'd like to back it up, and how long you'd like to retain that data. Now, let's review what we've learned. We talked about 3 different types of EC2 storage. EC2 supports Elastic Block Store, or EBS, which is like a flash drive or a detachable hard drive for your EC2 instance. We learned about instance store volumes, which are physically attached to the same machine the EC2 instance is on. Super low latency, but ephemeral data, which means when the instance is stopped or terminated, that data is lost forever. And then you have the Elastic File System, which is like a shared drive across many EC2 instances. We learned about the Storage Gateway, which is a hybrid storage service that connects on-premises and cloud data. And finally, we learned about AWS Backup. AWS Backup helps you manage data backups across many AWS services, including the ones we covered today, including the ones we covered in this lesson. So what do we need to remember for the exam? As with all of the services in this course, understanding the use cases is key. You want to understand the strengths and weaknesses of each services and whether they would be appropriate for a given scenario. EBS is great for whenever you need persistent data attached to a single EC2 instance. Instance store is super low latency, but that data is ephemeral or temporary. EFS is great for a shared directory across many EC2 instances, but remember the limitation that those must be Linux file systems. Storage Gateway is a service you'll use whenever you want a hybrid data storage model. This means some of your data is stored exclusively on the cloud, and some of it is stored exclusively locally. This can help you reduce latency or cut costs for data stored in the cloud. That's it for this lesson. This has been David Blocker, and please join us for the next lesson.